Welcome to On Chemistry. In this video, we are going to see aromaticity. It is a concept video. We will see step-by-step procedure and solved examples. What is inside this video? We will see the library to find the aromaticity. Basically, it will help you to solve the problem. Then, how to find aromaticity, step-by-step procedure to identify it. Then aromatic cations, aromatic anion, some tricky compounds. All the examples are taken from previous year question. It will help you to understand, maximize the clarity. Here I given the library of compound. It will help you to solve the questions on aromaticity. All the compounds are aromatic. Just check yourself, make yourself good at it. The aromaticity based on Huckel rule. Basically, you have to count the pi electrons. The types of aromaticity includes aromatic compounds, antiaromatic compounds, non-aromatic compounds, homoaromatic compound, quasi-aromatic compounds. Aromatic compounds are most common, which has 4n+2 pi electron, planar, conjugated, and it is stable, diamagnetic in nature. Antiaromatic means same, only difference is 4 and pi electron. Non-aromatic means mostly non-planar or not conjugated. Then homoaromatic, sometimes conjugation created artificially. There also you can get the aromaticity, that is called homoaromatic. Then quasi-aromatic. Quasi-aromatic means charge conjugation. Charge also help for the conjugation, which leads to the aromaticity, which is called quasi-aromaticity. Here the additional fact you should know is stability. Aromatic compounds are more stable, anti-aromatic compounds are least stable. So the order is aromatic, homoaromatic, quasi-aromatic, non-aromatic, anti-aromatic. Then how to find aromaticity? First, you should find the compound is planar or not. Mostly sp2 hybridized carbons are planar. So double bond means it is always planar. Then it should be cyclic. Then conjugation and delocalization of pi electron. Delocalization means moving, just rotating in the ring. Then count the pi electron. Double bond means 2 pi electron. Negative charge means 2 pi electron. Positive charge means no counting of electron. Lone pair means 2 pi electron. Lone pair is little tricky. We will see that in later. Then total pi electron should be equal to 2, 6, 10, 14 and 18. Basically we are adding 4 and 4. In Huckel rule it is 4n+2 pi electron. If you put 0 in n, if you give n equals 0, it gives 2. N equal 1 means 6. So on and so forth. Then we will learn by example. First one is simple system, naphthalene. Naphthalene is fused to benzene, totally 5 double bond, that is 10 pi electron. It is definitely planar. All carbons are sp2 hybridized. It is cyclic, conjugated. It has moving pi electron. There is no charge, no lone pair, so no issue of pi electron. So total pi electrons are 10 according to Huckel rule. 4n+2 pi electron where n equals 2. So naphthalene is aromatic. So in this way you can find all the compound whether it is aromatic or not. We will slowly getting into the tougher example. Here second example is aromatic anion. The charges are important because it provides conjugation. Here you see the order. The compound is planar, then definitely cyclic, then conjugated delocalized pi electron. Negative charge help for delocalization. Count the pi electron. There are 2 pi bonds, so 4 pi electron. Importantly, negative charge is there. so 2 pi electron. So total pi electrons are 6 pi electron. So if you count total pi electron, that is 4 plus 2, 6 pi electron. According to Huckel rule, it is 4n plus 2 pi electron where n equals 1, totally 6. The concept you have to learn here is negative charge provides conjugation, very important one. It provides conjugation as well as 2 pi electron. Then the next example, the compound with partial positive charge, 7-member ring with carbonyl compound. Carbonyl compound is the polar system. The charge separated between carbon and oxygen. Oxygen has negative charge, carbon has positive charge because of electronegativity difference. So the partial positive charge provide conjugation and help for aromaticity. So we will go by step. The compound is definitely planar. All are sp2 carbons. Then it is cyclic, conjugated with delocalization. Partial positive charge provide delocalization. If you count pi electron, there are 3 pi bonds. Carbonyl pi bonds outside the system, so we don't count. So totally 3 pi bond, 6 pi electron. Positive charge, we don't count it. So total pi electrons are 6. According to Huckel rule, it is 4n plus 2 pi system. That is n equals 1, 6. So it is aromatic compound. Here you have to learn two important things. Partial positive charge provide conjugation. You should treat it like positive charge and you should not count the pi electron outside the ring. Then the next example, pyrrole, 5-member ring with nitrogen and lone pair. We should find aromatic or not. The compound is definitely planar and cyclic compound. It is conjugated with pi electron. The important thing is how you should count pi electron, whether nitrogen lone pair helps or not. Here, if you count pi electron, 2 pi bonds, that is 4 pi electron, one lone pair participates because aromaticity creates a stability. So 2 participate create the stability. So total 6 pi electron. It is come under 4n plus 2 pi electron. According to Huckel rule, it is n equals 1 system. So pyrrole is aromatic. The important thing you have to learn here is pyrrole lone pair participate help for aromaticity, but in pyridine lone pair don't participate help for aromaticity. So the stability is the given factor. Then next tricky question, benzene mean one triple bond in benzene. So we will go by step. The compound is planar and definitely cyclic. The conjugation is there. Delocalization happening with pi electron. No lone pair, so 0 pi electron. Here you may confuse that triple bond 2 pi electron or 4 pi electron. Here you should count only 2 pi electron. Why? Because triple bonds are having 2 pi bond which is perpendicular to each other, which is the one parallel to the ring current participate, perpendicular to the ring current don't participate. So only 2 pi electron participates. So if you count it, you have 6 pi electrons. So 2 double bond, 1 triple bond. 1 triple bond participates 2, which comes under 6. That is 4n plus 2 system with n equals 1. So benzene is aromatic. The concept you have to learn here is in triple bond, count only 2 pi electron, not 4 pi electrons. Then we will summarize what we learned. You should memorize the Huckel rule, that is 4n plus 2 pi electron system, 2, 6, 10, 14, 18 and 22. Memorize the exception like biphenyl. While counting, you should know that anions provide 2 pi electron, cation don't provide any electron. Lone pair may or may not participate in aromaticity. Then you should know the table that Huckel rule table. Aromatic mean 4n plus 2 pi electron. Anti-aromatic mean 4n pi electron. Non-aromatic mean mostly non-planar and non-conjugated. If you look at the stability, aromatic mean more stable. Anti-aromatic mean highly unstable system.